The purpose of this video is to give you a recording of what we did in class today. We're starting with the add 5 program. So here's my Unix login. I have the add 5 HAL, which is the assembly language. I have it sitting here. So let's take a look at it. If I want to view a file in Unix without going into Pico, I just say more. And I see what we have here. And it looks pretty much like what we did in class. And so now I want to assemble it. And as I shared with you in the Blackboard announcement, if I want to assemble a program, that is, translate this into the machine code, the .hlx file, then the program I use is called HASM. And HASM means the HALIX assembler, which translates from assembly language, what you see here, into the machine code. And I must give it a source file, which is add5.hal. And it will show you that we're assembling first. If that is successful, that is, if we're able to produce a .hlx file, we will in turn execute that file all in one step. If you must run the file multiple times, you only need to assemble it one time. Just like if you compile one time, you can run over and over. So here is what you get when you assemble. Notice that it's taken what I had and it's given me back a listing. From this side to the end is what you originally put in. Over on the left is the translation of what you have put in. These first two columns are the translation. So if you look at this quickly, notice that here is the instructions, 14 instructions. Here's the data area, 6 data cells. And now we are ready to run. Okay? We're ready to run right now. So HALIX is actually the machine that's executing. And so we begin executing the code. It begins by telling you what the code is again. It turns the instruction opcodes into mnemonics or names of instructions so you can better read it. And now we're in a position to execute. We're adding 5 numbers, so let's try 1, 2, 3, 4, and 5. It should give me 15. And let's check. I have the inputs. I have the output of 15. So this is correct. Now, the file that we just looked at, from here all the way up to here, is called the trace file. Notice that it says add5.hlt. It's a HALIX trace file. The trace file is evidence that you ran the program. Furthermore, it's evidence of what the output is that is produced by the program. So we need to save that as a log file. So the first, we're going to run this multiple times, but I want to take the first version of it and copy add5.hlt into add5.log. I'm going to show you a little command now, and don't get crazy. Add 5, boom. And notice that it tells me how many lines are in these files. So what do we see? We see that add 5 trace file and add 5 log both have the same number of lines, the same number of words, and the same number of characters. Now I can run add 5 again, but this time I don't need to assemble it. I just run it, HALIX, and then when I run it with the HLX file, which is the translated version of the HAL file. So I will just say add5.hlx. And again, I'm executing. Let's give it all zeros. If I give it all zeros, I ought to produce a 0. So this is correct. Now, what's going on here? I have a log file that contains the first test case. HLT file contains the second. I need to combine those. And the command for that is called cat, which is a way of just appending one file to the other. So I want to take the add5.hlt and stick it on the end of, oh, wrong thing, yeah, and stick it on the end of add5.log. So with this, I am placing two execution outputs into a single file. Let's do the command again, wc add5.boom, and we will see that the log file has 152 lines and the trace file has only 76 because I have two copies of the trace file. The last thing we need to do is run it one more time, up arrow. Let's give it some big numbers this time. Okay. Now we get a big number which looks right, and that's our third test case, and we're going to now put that onto the log file. So with this, we have produced add5 dot what? We have the original source file which we need to submit. We have the HLX file which we can submit, and the log file. If you have, in fact, period. So how do we submit it? Well, we got to submit HS submit. The assignment is HALIX1. We can submit multiple files at one time. So I can say add5.hal, add5.hlx, add5.log. I can submit all of these at one time and say no, there is no checker, no, there is no checker. All right? And you can always check HS status add5 and see what's in the repository. I see these files that have been placed there. So I've shown you how to run your program with multiple test cases and how to save all the test case outputs into a single file. And with that, we're going to stop